This first lesson in this new unit is getting us started thinking about triangles. And we're going to spend some time in this unit and the next unit talking about triangles quite a bit. So the first thing we're going to talk about today is triangles in general and what this word similarity means when we start to talk about triangles. So you can see if you've got maybe a blank version of the note, or if you're just following along, you can see I've filled in some of these blanks already to give us a few basic things about triangles that we need to know from the start. So obviously to begin with, we can see that a triangle is of course just a 2D or two-dimensional shape with three straight sides. So that means a triangle has three sides, but also has three angles. And the sum of the interior angles just means when we add together all of the angles inside of a triangle, they equal 180 degrees. So from there, before we get any further with other triangle stuff, we need to also know how we can label them correctly. So that part I'm going to do right along with you. You can see some of the instructions there. If you don't have a printed version of this note, then you can just sketch out little versions of these triangles along with me. So first instruction says that each angle should get a capital letter and that each side across from it on the opposite side should get the same lowercase letter. So if I zoom in on this triangle here, I'm going to label it pretty simply. I'm going to call its vertices A, B, and C. That's what the three angles are going to be called, and I'm using all capital letters for that. But then our other instruction says that to label the sides, I go from angle A. If I go across the triangle to the opposite side to that angle, that's this side over here, I'm going to label it with the same letter, but with a lowercase a. And across from this capital B, this side over here, I'm going to label with a small b. Across from here, I'm going to label with a small or a lowercase c. So just keep that in mind. We'll be using that labeling method for a lot of different things going forward, both in this unit and the next one. Beyond that, though, there's different ways that we can talk about the types of triangles, depending on what type of angles are in them. So the first type is if we see a triangle that has all of its angles less than 90 degrees. Well, that term less than 90 degrees also has a special name for it. We call that an acute angle. So if all three of the angles are all acute, less than 90 degrees, then it turns out we just call the whole triangle acute. It's an acute triangle. Sometimes, though, not all the angles are less than 90. So what about if we have a triangle where one of the angles is exactly 90 degrees? Well, another name for a 90-degree angle is a right angle. And so we actually call these triangles right triangles because they have a right angle in them. And of course, that right angle, I'm sure you've seen this symbol before, is often represented with that little square where you see the angle. Sometimes, though, you might have one angle that's even bigger than 90. So if you do have one angle, it only takes one, if you do have one angle that's greater than 90 degrees, well, we call those type of angles obtuse. And so we call the whole triangle an obtuse triangle because it includes an obtuse angle. And of course, that would be this little angle in here. That's the obtuse angle, and that's what makes it an obtuse triangle overall. So the next question we have to ask is, what does similarity actually mean? So when we talk about two triangles being similar to each other, we don't just mean that they're kind of alike. We mean something very specific. One thing that's important to note is that it means the triangles are not identical. So they're not exactly the same size and shape. But they should be basically the same shape, except that one is bigger than the other. So for them to be similar, we need two important things to be true. First of all, we need to have, as you can see there, three corresponding angles that are equal. So in other words, for all three of the angles in a smaller triangle, I need to be able to find a matching, or in other words, corresponding angle in the bigger triangle to match it up with. And if I can find one in the bigger triangle that's equal to it, I've found a corresponding pair of angles. So if every angle in the small one has a one in the bigger triangle that it matches up with, then that's one step towards it being called similar. The other aspect is that the sides have to be something called proportional. meaning that if I take the length of the side in a smaller triangle and divide it by the length of the side in a bigger triangle, I should always get the same number when I do that same thing for all the different sides and their matching pairs. We'll see some examples of this as we go through the unit going forward, so don't worry about it too much, but these are just the two basic things we need to keep in mind as we go forward and go further. To think of this a bit more visually, let's think about this word corresponding in a way that we can actually see these triangles. So these three triangles here, we're going to say, are all similar to each other. And you can see that they clearly seem to have the same basic shape, but they all have different sizes. So the lengths of the sizes are clearly different. Well, we know that they should have corresponding angles that match. So for example, angle B from this triangle seems to match up with or correspond to angle E from this triangle and angle H from the largest one. If I maybe switch to a different color, let's try and do the same thing with the other angles. So if I look at angle A in the first triangle, it clearly seems to correspond to angle D, which also corresponds to angle G. And when I say correspond, I mean that just means matching up or goes along with. And with a third color now, we try green. Angle C corresponds to angle F, which also corresponds to angle I in the third and largest triangle. So that's what we mean by these corresponding or matching angles. If we want to think about the sides, they're going to be proportional. So for example, when I take two sides and divide them, like for example, this side divided by the length of this side, I should get the exact same number, the same decimal number, when I take two sides that match up with those and divide them. So for example, DE and then EF are two sides that match up with those. If I divide those two side lengths by each other, I should get the same decimal number that I got when I divided AB by side BC. That's what we mean by corresponding sides. So in general, we can say that if we want to check if two triangles are similar, there's two basic things we need to examine. We need to check if their angles give those matching or corresponding equal relationships, and we need to see what are the relationships of the comparable side lengths. And the comparable side lengths are just the ones that correspond or match up with one another. But this also raises the point that the letter order is important. We have to be very careful. So the order of the letters is going to be like our roadmap around the outside of a triangle, telling us where to start and where to go next and so on. So for example, if I write out triangle ABC, so triangle symbol and then ABC, I'm referring to the triangle up here, the small triangle. But I put those letters in a very specific order. I put angle A first, and then angle B, and then angle C. So I'm going to now say that it's similar to this next triangle beside it, but I'm going to match up the letters in the same way. So I'm going to list angle D first, and then E, and then F, which is following the same roadmap pattern that I used with A, B, and C. So specifically, going back down here, I can say that it's similar to DEF. That's the other triangle. And that's also similar to, scrolling up again to make sure we get the letter order right, GHI, to make sure that we put it in the same order that's being used in the others. So triangle, GHI. And then this little symbol that you see right here, that is the symbol that just means similar to. So it's a little squiggly line that's meant to be something similar to an equal sign, but we don't want it to be an equal sign because we don't want to say that the triangles are the same. We want to say that there's something that makes them very closely connected, but they are not equal or identical to each other. So that's all that little squiggly symbol means. In the last portion of this lesson then, we can talk about how we can look at this with some specific sides. And remember we talked about the fact that if I take one side in a triangle and divide it by another side, if I do the same thing with its corresponding sides in a larger triangle, I should get the same or an equal number. So, for example, this first one here is saying if I take the length of side AB from those triangles above and divide it by side BC, what should that be equal to? Well, I have to find a way to divide out matching angles, or matching sides, I should say, but matching sides that come from a different triangle. So specifically, focused in on this example, we're trying to see if AB is a side that goes very similarly with DE, what's a side in the bigger triangle that could take the place of BC? So I'm going to rewrite that in a place where we can see these triangles a bit more clearly up top. So here's the two main triangles that we're dealing with. And I'm going to rewrite that statement. It says that AB over BC needs to be equal to DE divided by something. And we don't know what that something is right now. So, well, think about what I just did earlier with my highlights, and maybe I'll even do an extra highlight just to really hammer it home. So I take this side AB and I divide it by the side BC. Well, what similar triangles tells me is that I should get the exact same thing or an equal thing when I take two other sides in the bigger triangle that correspond to those first two and divide them. So what would correspond to those? Well, the one that corresponds with AB is DE. That's the one that I already have on top. Well, what would we divide that by to try and do the same thing that we did in the small triangle? Well, we'd have to divide it by this one here, EF. So maybe I'll just emphasize it in a different color. We would get the same ratio or the same decimal number when we take the side length of DE and divide it by EF. I'll try one more example of this type with you, and then let you try and finish them off and see if you can check them using the completed version of the notes that I've posted as well. So we'll just do example B together now. Specifically, I'm going to take side DF and divide it by FE in the middle triangle. And then I need to find what would the sides be that would divide to make it equal in the larger triangle. So again, I'm going to rewrite this statement in a way that we can see the middle and largest triangles. Something like that. So again, if we rewrite that statement, it was DF on top over FE. And it was equal to something that we don't know divided by IH. Well, again, let's think about the sides in the first triangle. So in our first triangle here, we're taking side DF and dividing it by FE, dividing it by this side here. So if we want to make sure we match up that process in the larger triangle, that means the one on top should actually be GI. And then we'll divide that by IH, which is this one here. So that means the thing that we need to fill in on the top of our ratio is actually GI. That's the process for filling in the missing piece to each of those. You're trying to see, how can I make a matching ratio from one triangle with the other triangle? Continue to try those, fill them in as best you can, and you can always go back and check in the completed version of the note.